Okay, this brings us to the main session, the assignment exercise. And the assignment exercise is based on something that is called the Pell numbers. So if I just bring that up on my screen here, I copied that from Wikipedia. And if we don't look at the formula, if we just go and look at the text which is written here, it says in words, the sequence of Pell numbers starts with 0 and 1, and then each Pell number is the sum of twice the previous Pell number and the Pell number before that. So it's very similar to the Fibonacci series, but rather than taking the number, the previous number and the number before that, we take twice the previous number and the number before that in order to add them up to get what is now called the sequence of the Pell numbers. And if you go to Wikipedia, you can click on this link that is given here at the bottom. This is what the numbers should look like, 0, 1, 2, 5, 12, and so on. You can see the whole number there, but what we want to do now is we want to define a bit of a MATLAB script, a piece of code that actually calculates the Pell numbers and something called the silver ratio, which is defined very much in correspondence to the golden ratio in the context of Fibonacci numbers. So how do we go about making such a piece of code that does it for us? So the first thing is we now find a second way of interacting with MATLAB, which is no longer using the command line, but because we want to do, as you have maybe seen in the materials, of course, as you might suspect, defining the execution of a couple of numbers requires more than just one command. So it will be more than one line of MATLAB code. And rather than putting each of the line here in the command window, we actually make something called a script file. So I went into Open and I opened a script file here for us. So you can also do that if you are in a Macintosh or OS X environment, you can use Command N. There's various ways to open a new window. If you click on the Open, there's also ways of new, something that's existing before, and new for something that doesn't exist. The first option that you have is open a new script. This is what I did here, and it opens up something that can be saved as a file. So you get this thing. Our previous command window, in my case, has now switched to the right side. So that was what we had before. And in order to keep that small, I adjust my windows and will only look at it if we need it. And then we have more space for our commands that we want to enter in this file. If I press Save, click Save, we can give it a name, and I might just call it Pell because it's a script to go for the Pell numbers, or I call it Pell sub numbers. And as you can see, it will be saved on my desktop. If you have very good eyes, you might see it on the top right corner of my screen. It appeared there as a new file called the Pell numbers.m, and that's the file where this code will be saved for further perusal. So what do we want to do? Maybe we just enter our clear command window. Just if there's anything typed in there, everything will be clear before this code is run. What we need to do is we need to define how many Pell numbers do you want to have, and then we can say we will define an array to set this up. For convenience, and because many people have found that quite useful, set up arrays beforehand. I'll put a command. I put a comment. My line 3 is not being executed because I put the percentage in front, and so the rest of it will be ignored, and it can be used only to orient ourselves. So if we call our array Pell, this is supposed to contain the Pell numbers. Then I will just set it up as a bunch of zeros and I will suppress the output by putting a semicolon at the end. How many do we want to have? Say 20 Pell numbers, and then I define this array as 1, 20. The convention for those who are not yet so familiar with, the first number is the number of rows. That's one row, and the second number is the number of columns. So this will set up one row with 20 zeros in it, and it will be called Pell. The array will be called Pell. Zeros is the way of defining a matrix that contains nothing but zeros. So something to set up an array of a defined length. If we go back to our definition, and I'll just bring that up on my screen. The definition of Pell numbers stated that the first one is 0 and the second one is 1. So we can do that by further defining that the first number should be 0, but actually we don't need it because it's 0 already. If I just leave it for convenience, I don't really need to set it because we have set that up all as zeros. What I do need to define is that the second number is equal to 1, because the second number so far with only the first line executed will also be a 0. So I need to tell MATLAB, please give me the second number as 1, because that's how the Pell number sequence is going to start. So we have that done nicely by accessing our array called Pell and telling it, please take the element number 2 of that array and assign it the value of 1. Now we want to calculate them. And whether or not you have seen them, the way to do it is you take the first two numbers that you have and you calculate the third number. After you have calculated the third number, you take the second and the third number and you calculate the fourth number, and so forth until you reach number 20. So what we want to do is we want to use a loop, specifically something called a for loop. So our for loop looks like this. Starts with for and it ends with end. So that will be our for loop. And first we have to define how often do you want to have that loop executed, or how many numbers do you want to have calculated. So where do we start? Number 1 is equal to 0 and the Pell number 2 is equal to 1. We know that already. So we might as well start with the third one, which so far is 0, and which we want to have replaced with a new value. And of course we want to go all the way to 20, and we know how to define numbers from 3 to 20. It's using the colon in between those two numbers. So that will say, MATLAB, please start from 3 and go all the way up in integers up to 20. And then in between for and end, we have to place our command which tells MATLAB now how to calculate this number. So we say the Pell number and is going to be calculated according to some function. Now MATLAB needs to know which number successively is to be calculated in which way. So the way we do it is not give it the whole array, but to assign this array to a running index. And that running index is called k, and means k will successively take different numbers starting from 3 all the way up to 20. And then we can say, if it starts with 3, the first Pell number that we want to have calculated is 3. So we can just say the Pell number k, which is then starting from 3 successively all up to 20, which will be calculated one after the other. So we started by remembering our definition. The Pell number is calculated as twice the previous Pell number. Twice means 2 times. What is the previous Pell number? So obviously something from that array called Pell. And then we can say previous. Well, previous depends on what k you have, right? We can't say 1 or 2 or 3. We want to start with 2, of course, because that's the previous if we start with k equal to 3. But we need it to be 1 less than k. So the previous will always be 1 less than the one that we are calculating. If we calculate k, then the previous is k minus 1. And we need to add to this the one before that. So that's the Pell number, k minus 2. And we suppress output during the loop by putting semicolon at the end. And that's it. That's a for loop which tells MATLAB calculate from number 3 to 20 the missing 18 Pell numbers and put them in an array called Pell. So then they will be in an array, and of course we would like to see the output somehow, so we could either look at the numbers in the array or we can just conveniently plot. And if we say plot, our script should be complete. And I just tidy it up a little bit. I say plot figure, then we have it all commented. We have now a piece of code that starts with setting up an array. We define a for loop to calculate the numbers in this array, and we plot the result of this calculation in a plot, similar as we did with the sine wave. So we can do that by executing it, and if you do it correctly, something of that kind should show up, and it's a plot of the Pell numbers. And what you can see is very similar to the Fibonacci numbers. It starts very low. First number we know was 0, but when it comes to number 18, 19, and 20, we get to huge numbers, and you can see huge numbers on the Y scale. We have 7 times 10 to the power of 6. So this is a huge number. What is that number called? We can actually see that number in MATLAB. What is the last number called? Pell number 20. If we put that in our command window, it's 7 digits here. So we have 6,625,109 is the numerical value of that large number. If you want to have it slightly more conveniently plotted, what we can do is, rather than plotting the numbers directly, we can use a logarithmic plot, which is done by entering not the Pell numbers, but the logarithm of the Pell numbers, and plot the logarithm of the Pell numbers. You can find something that explains this in the materials, but if we execute now this code that we have done by pressing run here in the MATLAB tab, up here we'll get a new plot, and we'll get a straight line, which is more easily to see, and we'll get a straight line where the logarithm goes from 0 up to nearly 16. So it's more convenient to look at, and we have basically completed that task. For those who feel comfortable with this, we can go one loop further, and we'll just do it together. If you feel uncomfortable, maybe you have to practice a little bit more here. What we can do now is define the silver ratio. And I'll do that a little bit quicker than before. I say we want to calculate the silver ratio in a for loop, so very similar to what we had before. Before we do that, we will set up an array, and we might do that on the top where we already said we're going to set up arrays. That would be the silver ratio, so we call the variable silver, and we have a couple of zeros very similar to before, but because we need the ratio of 2 Pell numbers, it will be 1 less, so we go from 1 to 19 in setting up the array for the silver ratio. So now we know that we can fill in the numbers in that silver ratio, and we'll do it very similar to before. We define our running index, and that goes from 1 to 19. We want all of these ratios calculated, and similarly as before, we want the silver of that ratio, of that index calculated by some formula, output suppressed. So this is the same structure as before. The only difference being is we now go from 1 to 19 because we're only filling up an array that has 19 components. So how do we define the silver ratio? It's defined as the ratio of one Pell number over the previous Pell number. So we take a Pell number, and for the silver at K, so the first, how would you do the first ratio? Of course, you need to start with the second Pell number. So the second would be one larger than the silver ratio that you call, so that would be K plus 1. And then you divide by the current K. So let's take a look. If we want to calculate the first ratio of the two, you take the Pell number 2 divided by the Pell number 1 and put it in the first value of that array called silver. How about the last one? If we have 19 here, then we'll use the Pell number 20, which is correct because that's the last Pell number that we have, and divide it by Pell number 19, which is correct. So this is the way to set up our calculation of the silver ratio in a for loop. And of course, if I want to see this plotted, rather than plotting the log of the Pell numbers, I would replace this down here, and I would plot the silver ratio just using the plot command as before. If I go up and tell MATLAB to run this piece of code, pressing this green triangle up here, we get an error message. Why do we get an error message? So our last thing, we have made an error. So where is the error? Undefined function or variable x zeros. So something is wrong in the code. How can we define, how can we now identify the error? Well, MATLAB actually gives us a hint. This error came from line number 7 in this code. So how do we debug this? Of course, we take a look at code number 7, and what we can see is we have defined silver, wanting to set it up as zeros. But rather than using the command zeros, we have printed something that is XEROS, so was a typo. So MATLAB tells you that this is something that it doesn't know, something that you shouldn't be using unless you have defined it before. But of course, knowing that it's a typo, we can correct this, and we have a corrected piece of code, and I save it so that everything is also saved in the file. I decrease my command window again, and I can execute the code again, and I'll get a new plot, which is the correct one now, and no more MATLAB error message. So yes, we have our final result. We have seen, if you have worked through the material, you have seen what that looks like for the golden ratio, and here you get the silver ratio, which I don't want to go into detail, but you see that after a few initial ups and downs, the ratio between two subsequent Pell numbers levels off to just a single number, and that number, if I go and look here on the vertical axis, is the so-called silver ratio. If you want to have it numerically, you can also have that if you look up in your on your Wikipedia page. The silver ratio is defined as 1 plus the square root of 2, and we've seen before how to calculate the square root of 2. Namely, we use SQRT, and so we can check the numerical value 1 plus square root of 2 by MATLAB, typing this simple calculation in. It's 2.4142, which is of course exactly the same number which we had obtained in the plot or in our array of numbers called Pell. That brings us to the end of today's session. We have done a little bit of things around MATLAB, PWD, and a look at the paths, an important thing, because if we have something called Pell subnumbers.m, the file that we just wrote as a script, and I have it here on my desktop, then an easy thing, because it's there, you can actually execute it by just typing its name and pressing return, and it will do all the code that is in there. And this works because I have defined the desktop as one of my folders where MATLAB should look at. That's my startup folder.